Hello, this video will go over homework questions 54 through 58. Question 54. Graph each line below on the same set of axes. So on the first one, we have a slope of 3 and a y-intercept of -3, and this is just one way we could graph it. So I'm going to plot the y-intercept, and I'm going to go up 3 and to the right 1 a couple of times. And then I'm also going to go down 3 and to the left 1. Still keeps that positive slope. And then we'll draw on the line as straightest I can on this thing. And so that represents line y equals 3x minus 3. On B, we have a slope of -2/3 with a y-intercept of 3. So once again, I'll plot the y-intercept first. And then this one I'm going to go down 2 and to the right 3. Once again, do that a couple times just to make sure my line's as straight as I can get it here. I can also go up 2 and to the left 3. That still creates a negative slope. And there's the second equation. Once again, y equals -2/3 x plus 3. And then on C, we have a slope of -4 with a y-intercept of 5. Plot the y-intercept. -4 is -4 over 1 as a fraction, so I'd go down 4 and to the right 1. And do that once again a couple of times. Could also go up 4 and to the left 1. Once again, that slope of the line is still negative though. And then there's your third line, y equals -4x plus 5. Since I'm graphing all of these on the same coordinate plane, I want to make sure I label each of the lines. So question 54 was to graph each line below on the same set of axes. We've done that, we've labeled them, so should be good to go. Question 55. 55 talks about probability. Read through each of these so you understand what it's asking. Probability is used to make predictions. The way we find the probability is first off by labeling the probability is the capital P and then what it is you're looking for. The numerator is the number of success, what's your favorable outcomes to the total number of possible outcomes. So as we jump down to these 4 questions below, part A wants to know that you have a historic carousel, list all the animals there. Eric's niece wants for Eric to randomly pick an animal to ride. What is the probability that Eric picks a horse, a unicorn, or a zebra? So, how many of each of those do we have here? So let's take a look. We have 18 horses, 6 unicorns, and 3 zebras. So the probability of getting a horse, a unicorn, or a zebra is equal to 27 out of a total of how many animals can you choose from. So if you add up the rest of them, we should get a total of 48 possibilities. And if you divide those two numbers, since it does say that it wants us to express it as a percent, it doesn't tell us what to round to, so I'll just keep it exactly what we calculate. 56.25% is the probability that he's going to ride a horse, unicorn, or a zebra. Let's go on to B. Eduardo has in his pocket $1 in pennies, $1 in nickels, $1 in dimes. If he randomly pulls out just one coin, what is the probability that he will pull out a dime? So once again, we're looking for the probability of pulling out a dime. How many dimes are there? Well, how many dimes make $1? That would be 10 dimes to $1. And then we got to figure out how many total coins we have. So if we have $1 in pennies, that's 100 pennies. $1 in nickels would be 20 nickels, and $1 dimes we already said was 10. So that would give us a total of 130. We could reduce that to 1/13. And if we wanted it as a decimal or percent, we could approximate it. It wouldn't be exact. We could approximate this to about 7.7%. So almost 8%. Alright, part C. Probability of rolling an 8 with one regular die if you roll the die just once. Well, if we're talking about a regular die, then that would be numbers 1 to 6. And there is no 8 on that dice. So what is the probability then of rolling an 8 when it doesn't even exist on there? It would be 0. It would be 0 to 6, or once again 0%. And then part D, probability of a dart hitting a shaded region with the picture that you see if the dart is randomly thrown and hits the target at the right. So the probability of that, well, how many shaded regions do we have? 1, 2, 3, 4, 5. Out of a total, 6, 7, 8, 9. So that would be 5 out of 9. As a decimal, that would represent, or as a percent, that's approximately 50, we're on to the nearest whole number, 56%. So make sure you take a look at that if you need to. There is a section in the math notes that goes in a little bit more detail as well. Question 56, the distance along a straight road is measured as shown in the diagram below. If the distance between towns A and C is 67 miles, find the distance between A and B. So between A and C, 67 miles. Find the distance between towns A and B. Well, we need to figure out what the x value is, but we know if the total distance is 67, then we should be able to add the two distances together to get the total. We can combine like terms and then solve the equation. Subtract 4, divide by 7. So x is equal to 9. So if we plug that in to each of these, that would give us a distance from A and B to equal 45 minus 2 would be 43 miles. And B and C would be 18 plus 6, which would be 24 miles. So find the distance between towns A and B. And that distance is 43 miles. So make sure you answer the question and also label. Question 57. For each equation below, solve for x. Show all work. The answers are provided so that you can check them. If you are having trouble with any solution and cannot find your errors, then you should ask your teacher for some extra help. So in part A, I'm going to go ahead and combine the three terms, and that would be 4x is equal to 15 divided by 4. 15 divided by 4 is 3.75. B, once again, combine the left side. We got 3x minus 2 minus x. That would be 2x minus 2 is equal to 7 minus x. Add x to both sides. We get 3x minus 2 equals 7. Add 2. 3x equals 9. Divide by 3. X is equal to 3. Next, C. I'm going to go ahead and distribute 3x minus 3, and then I'm going to combine my like terms on the right side. So that would be 5x minus 3. Then we'll solve by getting variable term on one side and the constant on the other. So, as always, it doesn't matter the order that you solve the equation. Just make sure you're using your inverse operations to solve. So it looks like we're going to get x equals 0. Part D, we have to distribute twice. So we'll get 6 minus 3x equals 10x minus 35 plus 2. We can then combine our like terms. I'm also going to subtract 10x. So we get 6 minus 13x is equal to negative 33. Subtract 6. Negative 13x is equal to negative 39. Divide by negative 13. X is equal to 3. So far everything's checking out. E, we have 26 over 57 is equal to 849 over 5x. A couple ways we could go about solving this, but I'm going to go ahead and get rid of the denominator. So I'm going to do it in 2 steps. I'm going to multiply first by 57. That will cancel the left side in the denominator. And then the right side, we're going to get 48,393 over 5x. And then I will now multiply by the 5x to both of them. So I get 130x. Now this 5x just cancels, so that stays at 48,393. And then divide both sides by 130. And so x is approximately, we get a decimal that goes on for a while, so 372.25. Alright, and then the last one, scoot this up a little bit, we're going to go to F. And this one I'm going to do in one step. I'm going to multiply by 6, and then that way it cancels both denominators. So it'll look like this. 4x plus 1 over 3 times 6 over 1 is equal to x minus 5 over 2 times 6 over 1. I'm going to cancel. 6 divided by 3 is 2, and 6 divided by 2 is 3. So then I can take the 2 and distribute, and the 3 and distribute. So that's 8x plus 2 is equal to 3x minus 15. Subtracted 3x. Subtract 2. 5x is equal to negative 17 divided by 5 is negative 3.4. So continue to work on solving all sorts of different types of equations throughout all these homework assignments. Question 58. The three-dimensional shape below is called a cylinder. Its bottom and top bases are both circles, and its side is perpendicular to the bases. What would the shape of a flag need to be in order to generate a cylinder when it rotates about its pole? You may want to refer to problem 149 to review how flags work. So if we pictured this, here's the flag or the pole, and you want it to represent a cylinder. So kind of get that idea in the middle there as it rotates around. And if you did that, then you could just have a rectangle. And think about as that rotates, it's just going to create this width here as this dimension, and then the length as this one. So the flag would need to represent a rectangle.